Hi, this is Claire and I'm just setting up a problem here. I'm drawing a compass rose because I'm going to solve a navigation problem about a bushwalker. And these are often problems that use compass bearings. So here we have the problem. A bushwalker walks 3 kilometres on a true bearing of 60 degrees from A to B. So here we have A at the centre of the compass rose, and we can measure 60 degrees from due north down 60 degrees, and we get a point here, and we'll put a line through that point. So that is the bearing 060 degrees true. And we'll just say that this is B here. Okay, so this bushwalker has walked 3 kilometres along this bearing. Now you can set a bearing on an actual navigation compass and do that. And you can walk 3 kilometres and stay on that course, ensuring that your needle stays on the bearing of 60 degrees. So this is 3 kilometres. Now the problem has said we've walked on the bearing of 60 degrees, so this is 60 degrees here, that angle. Now we're asked to find how far east B is from A. So here you are at B. This would be your easterly coordinate and this would be your northerly coordinate. So we'll draw a right-angled triangle here, which is kind of handy because that means we can use both Pythagoras and trigonometry to solve this problem. I'll just try to get it actually at right angles. And we'll put in the right angle symbol here. So this distance here is the easterly distance the hiker has walked, and this distance would be how far north they've walked, but they're actually on a bearing of 060 degrees true. Right, so as you can see, you've got a right-angled triangle, but you have 60 degrees here, so you need to calculate this angle. And because this is a 90-degree angle, you say 90 minus 60 is 30 degrees. And now you have a length and an angle. So here you could probably use trigonometry. You wouldn't use Pythagoras because you don't have 2 lengths. Okay, there's the angle 30 degrees. Opposite that is the opposite side length. Opposite the right angle you have the hypotenuse, and the other side length is the adjacent. If you're asked to find an easterly distance, you'd be looking at the adjacent. So you write so, ka, toa, and you need to find the trig ratio that involves the angle theta, the adjacent, which is what we want, and the hypotenuse. So the adjacent and the hypotenuse is the cosine. It's the cosine ratio. So we'll write that ratio down. Cos theta equals the adjacent over the hypotenuse. So the adjacent is our unknown. Let's call it x. So cos 30 equals x over 3. You don't put the unit in the middle of a question. So the unknown is on the top, so you times. So the 3 will come up and multiply by cos 30 degrees. So 3 times cos 30 degrees equals x. Okay, so on your calculator, you can work that out. Turn it on, and 3 times, see that I'm in degrees there, cos 30, close the brackets, enter, and I have a exact form answer, 3 root 3 divided by 2. To convert that to a decimal, you use this arrow to arrow button down here. I'll just see, can you see it? It's there. So select that and you get the rational approximation, or a decimal, which is, if we go to 2 decimal places, it's 2.598. So the 8 would round that 9 up to a 10, and that would round the 5 up to a 6. So it'd be 2.60. So x equals 2.60 kilometres. Because your unit used the unit of kilometres in the question, the answer will have the same unit. So the northerly distance you went was the easterly distance was 2.6 kilometres. You could also work out the northerly distance, but you could actually use Pythagoras to do this. So if you wanted to use Pythagoras, let's call that distance here y. You would write 3 squared, which is the hypotenuse, equals x squared, which is 2.6 all squared, plus y squared. And that's to find y. Okay, so 2.6 squared and 3 squared. We need to rearrange this now to make y the subject. So y squared would equal 3 squared minus 2.6 all squared. And you can simply put that on your calculator. So, clear? 3 squared minus 2.6, and you don't have to use brackets on your calculator, squared, equals, and it's 2.24. Okay, but that is y squared. So you will need to find the square root of that. So y equals the square root of 2.24. So on this calculator, you can go second function square root, and then I can arrow up and grab that, highlight that, and just push enter, and it types it back in for me. And then simply, if I want to, I can come out from the square root button. That's a good idea to do that. And go enter. And it's to 2 decimal places. Again, it's a tricky one to round. 1.496. So the 6 rounds the 9 up to a 10. And that 10 will make the 4 into a 5. So it's 1.50. So y equals 1.50, and that is in kilometres. So we have found here the northerly distance that the hiker has walked is 1.5. The easterly distance is 2.6. The second part of this question says, what bearing is A from B? So just say you're standing here and you want to walk back to A, but you can't see A because there's lots of bush in the way. You'd have to set your compass bearing, your compass on the bearing, a bearing to walk back. So how would you work it out? Well, guess what? We're going to use alternate angles. So we have the north line here, the north-south line. And we also have a north-south line here through B. Okay, those are parallel. So we can put on our parallel lines, they're parallel. Okay, if this here is 60 degrees here, this will also be 60 degrees here, because you have a transversal through the parallel lines here. There's my transversal. And you have Z angles. There's my Z angles. See them? Right. So you have 60 degrees. To work out the bearing which is clockwise from north, which will be around here to that line there, you would simply add 180 from here to the 60 degrees, and you would find your bearing to set your compass back. So the bearing from B to A will be 180 plus 60, which equals 240 degrees. Okay, so the answer of that is 240 degrees true. And that's what you'd set your compass on to walk back to your starting base. Now that's a back bearing. Okay, and a back bearing means you're walking back on the same line you just walked, and it's just doing a 180. So the difference between a bearing and our back bearing is always 180 degrees, which is that distance there. So that's something we can talk about in class when we can actually act it out. But thank you for your attention, and I'll talk to you later. Bye-bye.